I don't think anyone.
Alright, today we are going to take a look at similar polygons, right? Similar and congruent are closely related ideas, right? We talked a lot about congruent triangles in previous chapters, and actually other congruent figures as well. So we said congruent meant same size, same shape, right? Similar polygons are going to have the same shape, but maybe a different size. The way that we define similarity is that we're going to start by looking at triangles, but then we'll look at a few other shapes as well. Similarity means the two figures have congruent angles, right? So all of the angles are going to be exactly the same measures between corresponding pieces. And then the sides are going to be proportional. Right? So we'll take a look at what that means here in just a second. But if I look at this example between triangle ABC and triangle XYZ, okay, I'm told that they are similar. I'm told triangle ABC is similar to triangle XYZ. And this symbol here, just a little squiggly line, is our symbol for similar. Right? If you remember, our symbol for congruent was an equal sign with a squiggle over top. Our symbol for similar is a little squiggle line. Right? So we're told that these two triangles are similar. So that means two things. Corresponding angles are congruent, and corresponding sides are proportional. So just like we did when we had a congruence statement, our similarity statement tells me which pieces match up. So I can just look at the statement. I don't even need to look at the picture. Just from this statement, I can say that angles A and X correspond. So if I'm listing my congruent angles, I can say angle A is congruent to angle X. Then I can say angle B is congruent to angle Y. And then I can say angle C is congruent to angle Z. Right, so the angles in similar triangles have the exact same measures. The sides, then, we say are proportional. So what that means is we can write corresponding sides as a fraction. So, again, I don't even need the picture. I can just look at my statement and say AB would match up with XY. So what I'm going to do is write that as a fraction. I'm going to say AB over XY is going to be equal to the fraction of the next pair of corresponding sides. So BC and YZ. And then my final pair of corresponding sides would be AC and XZ. So what we'll look at in the next example is if we had numerical values for all of these would all create the same fraction. Right? That's what it means to be proportional. Right? Corresponding sides end up creating the exact same fraction. Okay? So in example 2, that's what we're going to do here. This is a pair of quadrilaterals that we're saying are similar. Right? Well, actually, we want to determine whether they are similar or not. So, to test for similarity, what we want to do is compare each pair of corresponding sides. And in this example, they wrote out those fractions for us. WX and PQ would correspond, WZ and PS, ZY and SR, XY and QR. Those would be our pairs of corresponding sides. So, if I write those as fractions, if I write WX over PQ, that would be 12 over 8. We can reduce that. What would it reduce to? 3 over 2. Then we can do the same thing for xy over qr. 18 over 12. Again, that will reduce. What will 18 over 12 reduce to? 3 over 2. And if you don't know, if you can't do that in your head, that's okay. You can use a calculator to do that. You can just put 18 divided by 12 in the calculator and change that into a fraction. So then our other two pairs, we get yz over rs, so 15 over 10. That will also reduce to 3 over 2. And lastly, zw over sp, 9 over 6, also reduces to 3 over 2. So, I got the exact same fraction for all four pairs of corresponding sides. That means that the corresponding sides are proportional. And we can say these two quadrilaterals are similar. Okay? So, if we get the same fraction, right, that's what this meant up here. Those sides would give us the same fraction if I write them with their actual side lengths. The last kind of idea on the front here is another vocab term, a scale factor. And we looked at scale factors when we did dilations, okay? But now we can talk about scale factors between these similar figures. So the scale factor, depending on which way we say it, right? So if I say the scale factor of wxyz to pqrs, I would say that scale factor is 3 over 2. But if I say it the other direction, if I say the scale factor of pqrs to wxyz, right, that would be like putting these values over these values. That would be 2 over 3. Okay. Questions so far? All right, then in these exercises down below, for numbers 1 and 2, it just asks us to list the pairs of congruent angles and then the proportions. So there aren't any numerical values here. We're told these figures are similar, and we want to write the congruent angles and the proportional sides just like we did in the first example. And then in the bottom two here, we're doing what we did in example 2. We're determining whether each pair of figures is similar or not. Okay? So actually, let me give some values here for number 4. Let's say that this is 5 and 5, and this is 8 and 8. Right? So let's take a few minutes here, right? Write out our congruent angles and proportional sides for 1 and 2, and then determine whether these two figures down at the bottom are similar or not. Right? So I guess in number 4, we're looking at triangle PQR and then triangle PST, right? The larger triangle there. So let's take a few minutes and try a couple of these. So make sure on numbers 1 and 2 you're using the statement. Right? Statement tells you all you need to know about Alright, take a look up here at our answers. So for numbers 1 and 2, it was just a lot of listing out of congruent sides and then proportions. And to do that, remember, we're just using the statement. And we don't even need to look at the picture. The statement tells me everything I need to know to list out all the pairs of congruent angles and the pairs of proportional sides. Then for numbers 3 and 4, we're determining whether these figures are similar or not. So in number 3, one of our things for two polygons to be similar is that all the corresponding angles have to be congruent. Well, in the second figure, I have a right angle. There's no right angles over here. So these two figures cannot be similar because all the angles are not congruent. In number 4, we kind of had two triangles on top of each other. So it may help if we split them apart like this. So triangle PQR and triangle PST. They tell us then that each pair of corresponding angles are congruent, right? These two angles are congruent, these two angles are congruent, and then they share angle P. So then we just need to check to see if corresponding pairs of sides give us the same fraction. So if we do PQ over PS, PQ over PS, that'll be 5 over 10, which would reduce to 1/2. If we do PR over PT, that'll be 8 over 16, which would be 1/2. And then QR over ST, 11 over 22, which would be 1/2. So since all three of these pairs of corresponding sides give me the same fraction, these two triangles are similar. I made those. Yeah. So they just gave us that PQ and QS were the same with those little dashes, and then PR and RT were the same with those little dashes. So I just made up numbers to go along with that. All right. Any other questions on the fronts? All right, then let's flip over to the back here.
It's the thing that we have today, 7th and 8th period.
It's going to shorten both 7th and 8th periods by like 15 minutes. And then it'll start at like 2 o'clock.
What is it about?
American Heart Association?
Yeah, maybe
Is
not.
that what it was?
What is that?
Sleepy and healthy. Alright, so on the back, we are going to use the idea of similar triangles. But I guess not just triangles, similar polygons to solve for missing sides. So we know that we can set up proportions for corresponding sides. These two are set up so that it's easy to see which sides correspond. And we can say RS and MN, and then ST and NP, and then RT and MP. So what I can do is write a proportion. Let's say I want to solve for x first. Okay, so I'm going to write x over 13. I'm going to match up those corresponding sides. And I'm going to set that equal to. Now, I only want to have one variable in this equation. So I need to make sure that I pick out a pair of sides now that don't have a variable in them. Well, 32 and the 16 are corresponding sides that just have numbers. So I can say x over 13 equals 32 over 16. One thing, when we're setting up these proportions, it's important to make sure that we go in the same direction. What I mean by that is since I wrote my first fraction as x over 13, I went big triangle over little triangle. have to do the same thing for my second fraction. I have to go big triangle over little triangle. Right? So now to solve this, does anybody know how we're going to solve something like this? Sebastian?
Watch. Never mind, I lost.
Say it again. I think you said it. We're gonna cross multiply, right? So cross multiply, I'm just gonna multiply x times 16 and then 13 times 32. So x times 16 is just 16x. And then 13 times 32, 320, 416, beat me to it. Right? So then, one final step to get x by itself would just be to divide both sides by 16. So what's 416 divided by 16? 26. I'm going to show them that way in a second.
You saw how I did it, right?
Yes.
I didn't do that one.
To solve for y, we want to do something similar. Right?
Why was 19?
So sure, we can do y over 38 equals. So again, just like we did for this proportion over here, where we know the values. So yeah, we can do the 16 and the 32 again. And just like we said, we need to be consistent. So since we did y over 38, we would have to start with the little triangle and do 16 over 32. Okay, so little triangle over big triangle equals little triangle over big triangle. Okay. Then cross multiply. So 32 times y, be 32y. 16 times 38, 608. Thank you. Divide by 32. And we should get 19.
Do that.
Yes, and I'm going to show you how I did that in my head here. Okay. So this method is the fail-proof method to do this. Right? This setting up a proportion will work every time. There could be some shortcuts though to make the math a little bit simpler. In this problem, if I look at this ratio, 32 over 16, well, 32 over 16 would be
You get one.
2 over 1. Yeah, right? I can actually reduce this fraction. Okay, before I do any math, you're allowed to always reduce fractions. So instead of saying this was x over 13 equals 32 over 16, we could have said x over 13 equals 2 over 1. Okay, we could have reduced this first. Right? Well, then if we cross multiply, we just get 1 times x, which is x, and 13 times 2, which is 26. Okay? We can also, along this same idea, we're saying, well, 16 is just half of 32. Well, if I want to get this side, I'm just going to take half of 38. Half of 38 is just 19. Same thing here. If I'm going in this direction, well, this side is just going to be double this side. So 13 times 2 is 26. Okay, now it's not always that easy. It's not always just going to be multiplied by 2 or multiplied by 3. Sometimes that value may be a little bit uglier, right? Like in this second example, I need to find the perimeter of each triangle. So that means I need to find both of these missing sides here. So we can call one of them x and one of them y. But we're going to go through the same process that we did here in the first example. Right? We want to set up a proportion matching up the corresponding sides. So if we solve for x first, x would match up with 10. So we can say x over 10 equals, and then I want to find a pair of corresponding sides that I know both values. So we can do 12 over 8. And we could just cross multiply from there. Or we could reduce this fraction first. It's totally up to you. And if you want to reduce and make the math simpler, go for it. If you don't care about making the arithmetic simpler, just cross multiply straight from here. Okay? If we cross multiply straight from here, we'll get 8x equals 120. Divide both sides by 8. And that gives us 15. If we do the same thing for y, we can do y over 12 equals 12 over 8. Cross multiply. We get 8y equals 144. Divide by 8. And we get 16.
15. I got 18.
My body was
18, yeah. Alright. Then the final part would be to find the perimeter and scale factor. We'll finish this one up tomorrow. No homework tonight. Alright.